Now, that allows me to ask problems that are kind of messy, and yet they're pretty darn easy. This is an old exam problem. I love it. It's got potential energy, kinetic energy, spring energy, it's got friction, it's got it all. Now, on the back of this page, there's a special problem that will be due next Wednesday. It's not part of this homework assignment, but it will be part of the next homework assignment. Okay, in this problem, a block is released from rest at point A. It slides down this frictionless track to B, and then it encounters a rough patch that's 2 meters long. And then it bounces into this spring. The spring causes it to reverse direction and go back the other way. Now, the first question on this problem, when it was on an exam, was only worth 2 points, meaning it's easy peasy. Find the work, see we misspelled it there, find the work, if any, done by the ramp on the system as the block moves from A to B. Now, the answer, of course, is 0. And everyone in the class got that right. But most people in the class only got 1 of the 2 points. Because they said there's 0 vert because it's a frictionless ramp. Well, that doesn't prove it. The ramp is still pushing on the block. You need to argue that it's pushing perpendicular to the motion, and hence does 0 vert. Now it gets interesting. Find the kinetic energy of the block at point B. With your neighbor, give that a try. See what you can come up with. Okay, let's do it together. This problem caused a morale problem in my class. Because when I posted the exam, my solution to this problem was this. And I had some upset students. They came at me, they just said, "Greg, you lying sack of spit! You told us the kinetic energy was 1/2 mv squared, you even made us memorize it, and then on the exam you changed your mind. It's not 1/2 mv squared anymore, it's mgh. You lying sack of spit." Now, all I did in my defense was skip a few steps. What I should have put on the solution key was that initial energy is equal to final energy unless there's vert done. Well, I'm going to choose my initial point to be A. I'm going to choose my final point to be B. Because I know the energy at A, I'm looking for the energy at B. I just said that there's no vert done by the track between A and B. So I've got 0 vert. I then say at A, what kinds of energy do I have? Well, the block's not moving, no kinetic. The spring's not compressed, no spring. I've got potential energy. gravitational potential energy. I then go to point B and I ask, what flavors of energy do I have? Well, it's moving, so I have kinetic. It's on the floor, so I don't have any gravitational, and the spring's not compressed yet. No spring. And then I reminded myself, this is what I'm looking for. So if I know this, I know that. So I said, well, this is just mg h at A is equal to the kinetic energy at B. And that's what got me in trouble. Okay? There's those steps in between. If I know the potential energy at A, and I know that I didn't get robbed as I went from A to B, then I know the kinetic energy at B. Check to see if your neighbor's okay with that, or if they're still upset about the lie. So what we're saying is that I had 80 joules here, I must still have 80 joules there. And then we get robbed. Okay? So, next thing we want to find here is the magnitude of the frictional force by the rough section of track. Can you do that in your head?
Yes.
Good. What did you get? It's a 10 kilogram block. That means the weight's going to be 100. The normal's going to be 100. I take that normal and I multiply it by the 0.3. I get a friction force of 30 newtons. You ought to be able to do that in your head. Then we ask, how much kinetic energy do we have at C? Well, we go back to the same starting point. The energy initial is equal to the energy final, except when it's not. Well, if as initial I take B, and as final I take C, I know that at B I had 80 joules of kinetic energy. I then have negative Vert done by 30 newtons over a distance of 2 meters, and that's going to give me my kinetic energy at C. This is going to be 80 minus 60 is equal to the kinetic energy at C. So this is just like like finances. You're walking down the street with $80 and someone steals you. They take $60. What you got left? That's all there is. And then we're told that the spring constant has a value of 160 newtons per meter. How far is it compressed? What's the delta S of the spring? That delta X should be a delta S, I'm sorry. When the block comes to a momentary halt. You know, do that on your own. We're out of time. Have a good weekend, people.